Up next, we have a presentation by, it's a powerful case study, as it says, talking about high voltage, or as my daughter would say, that's a bad joke, so don't say it again in public. But we do have Clarence Sumrall from the Holmac Corporation. He's the maintenance, he's the corporate director of maintenance at Holmac. Mr. Sumrall has been employed at Holmac in Bay Springs for 5 years. He's a graduate of Jones Junior College and has 16 years of experience as a tool maker, 13 years of experience in tool management and tool engineering, and 13 years experience in maintenance management. Please welcome Clarence.
Good morning. I am Clarence Sumrall. I'm Corporate Director of Maintenance for Holmac Corporation in Bay Springs, Mississippi. I want to introduce you to our company a little bit before I talk about our projects. We have 3 plants in Bay Springs. Plant 1, we build small to medium steel fabrication, build vacuum trucks and trailers. We also, probably mid-summer, we're going to start building truck-mounted forklifts. We have the capability to burn shape parts in our burn facility. Plant 2 will build hydraulic cylinders, and Plant 3 will build pack-mat garbage trucks and hammerhead truck bumpers. A little about who we are. Our mission statement is to be a world-class manufacturer in every marketplace which we participate. Our quality elements are quality product, and that being defect-free, and having on-time delivery, customer satisfaction, and always trying to continually improve. Our environmental policy is to be a responsible corporate citizen and protecting the environment. And our main objectives and commitments are to investigate the reduction of hazardous and toxic chemicals, reduce, reuse, and recycle waste in packaging, and improve the efficiency of energy waste. Some of the proprietary parts that we build in our Plant 1 facility, I'm going to run through these pretty quick, so I just want to introduce you to some of the things that we do. We build vacuum trucks and some pump trucks and trailers. We build different types. We build aluminum vacuum products to go on trucks. We build liquid transport trailers. We also have like our pack-mat portable restroom vacuum trucks. We build different types, like I say, of vacuum trucks for the oil field services and for the winch trucks for the oil industry. Newest member to the Holmac family of products is the Donkey truck-mounted forklift, which will probably be in production with those in midsummer. Plant 3 proprietary products. We do build the Hammerhead line of truck accessories. This is a picture of the Hammerhead truck. Rocky Ridge is one of our customers. This is a Rocky Ridge Jeep rear bumper, Rocky Ridge Jeep front bumper. We build knuckle boom loaders. We build different variations of knuckle boom loaders. We also build pack-mat garbage trucks. Our environmental project, which is called High Voltage, a powerful case study. A little about the project background. In our Plant 2 facility, we have on the paint line, we have a 5-stage washer. That's heated in stages 1, 3, and 5, but we use electrical heaters to heat those stages. We also use chemicals in all 3 of the heated stages. All right, we've built a new paint line, and in that we built a new 5-stage washer. We built it internally. Stages 1, 3, and 5 are still heated, but they're heated by a natural gas-fired, it's a boiler, but it's more like a water heater, if you will. The pump, motor switches, valves, things like that are still electrical. And we also use cleaning chemicals on all 3 heated stages. Our old 5-stage washer ran 3 shifts a day. Our new 5-stage washer runs 1 shift per day. Team members on this project were members of maintenance, a design engineering group, general manager, and myself. The project scope was to create a baseline of power usage on the existing 5-stage washer. The project was due on the 1st of June 2014. It was a continuation from the previous year. A project charter is a living document that lists tasks, target date, and completion dates, responsibility assignments, and significant aspect being addressed. This is a copy of the charter on this project where we list the project name, significant aspect, the objective, target, task, and responsibility assignments. This is a tracking sheet that I developed to track the kilowatt hours that we use weekly on an 05-stage washer. We also tracked MMBTUs, which is million BTUs. This is a list of the power consumers we identified on the 05-stage washer. You'll see we've got fans, pumps, motors, heaters. We've got 8 heaters in that 5-stage washer. We've got 5 18,000 watt heaters, and we have 3 10,000 watt heaters. I want to make a note that we are using 8 heaters in that washer. All right, this is a picture of the power monitors after we installed it to monitor the power on the 5-stage washer. We used 2 monitors. We used 2 monitors because we had 2 power sources going into the washer. This is a close-up picture of the power monitor. Upper right-hand corner, it has the running kilowatt hours. Second number is the line voltage, and the next 3 numbers are the amp draw on all 3 legs of power. The main panel monitors 2 18,000 watt heaters, 3 10,000 watt heaters, motors, pumps, and everything else that's electrical on that panel. Stage 1 heaters monitors just 3,018 watt heaters. Our plan was to monitor readings weekly until the new washer was online, and a comparison would be made on the power used on the old 5-stage washer versus power used on the new 5-stage washer. My current environmental project is energy usage on a new 5-stage washer. My team members are members of maintenance, our general manager and myself. The project scope was to determine the direct correlation of power on the old 5-stage washer versus power used on the new 5-stage washer. The project is due 1st of June of this year. This is a charter, a copy of the charter that we use on this project, where we've listed the project name, significant aspect, objective, target, task, and the responsibility assignments. This is the tracking sheet I used to track the data collected from this project. Track kilowatt hours, and we're tracking the natural gas usage to get a baseline on the natural gas, so for future reference. Power consumers here are identified on that new 5-stage washer. If you'll notice, there are still motors, exhaust fans, pumps, etc., but there are no electrical heaters on in this power consumer package. Comparison of kilowatt hours used on the old 5-stage washer versus new 5-stage washer. The blue bars indicate the power used on the old 5-stage washer, and the maroon bars indicate the power used on the new 5-stage washer. We averaged 6,590 kilowatt hours per week on the old 5-stage washer, and we averaged 1,895 kilowatt hours per week on the new 5-stage washer. This is for just the first 24 weeks of monitoring since we started monitoring the project. The cost comparison is pretty much the same as the power usage. The blue bars indicate the cost on the old 5-stage washer, and the green bars indicate the cost on the new 5-stage washer. The old 5-stage washer cost $667.25 per week to operate. New 5-stage washer has cost $191.97 per week to operate through the first 26 weeks of monitoring. We also, a part of this project, were to generate a baseline of standard cubic feet of gas used to operate the boiler. We've averaged 45,902 standard cubic feet of natural gas per week. MMBTU that we've used on the old 5-stage washer versus new 5-stage washer. I chose MMBTU because it's a common unit between kilowatt hours and natural gas, but the MMBTU used on the old 5-stage washer was 539.46, and the new 5-stage washer we used 158.28 MMBTU, and this is for the first 24 weeks of monitoring. Some other projects we worked on at Plant 2 was 2012. We had an air leak project. If any of you have ever been out in your plant without the plant running and you heard a hissing noise, that's what we're working on. We're trying to fix the leaks. We're trying to capture cost savings, and we're also trying to capture energy savings. We calculated, when we did this, we calculated we had a 53% compressed air waste throughout the plant. So we performed air sweep with the plant not running. We cranked the air compressor up, found air leaks, performed air sweep. Took several weekends to do this, but we got it all done in like 4 weekends. And we got the compressed air waste down to 19%. We set a target for 25%. And through this project, it caused us to generate a quarterly PM in our maintenance database to check for air leaks. This is the environmental project charter on the air leaks. Again, we've listed the project names, significant aspect, the objective, target, and task and responsibility assignments. Another project we worked on, in 2013, we worked on material storage and maintenance project. The project scope was to reduce the opportunity for leaks and spills in coolant and used oil areas and to improve the maintenance area. This improved maintenance area was added because we had an environmental audit, and the lady that did our audit suggested we clean up the maintenance area. This is a charter on material storage. Again, we've listed all the critical items as in the previous charters. This is a picture of the coolant area outside of maintenance before we actually started cleaning it up. You can see what she was talking about when she said it really needed cleanup. This is a coolant area after we did the cleanup, and we also added the oil drum containment provision. And this is the coolant area and the tote containment area after the cleanup. This is an overall picture of the whole area. Getting to this point wasn't that hard. Just maintaining it is a little harder than getting it to this point. This is the used oil area outside our plant before we actually made any containment provision. You can see we had minimal containment for that tote storage. This is a picture of it after we built the oil containment and cleaned up that area. Now if we have a puncture or spill in those totes, we can contain all the oil that's in those totes. This project was also used as an enhanced annual project in 2012. We had in 2014, 2015, we did a welding gas usage. Maintenance personnel repaired several argon gas leaks throughout our hard plumbing, welding gas hard plumbing. Our welding gas leaks are checked and repaired by maintenance personnel monthly, and we generate a monthly PM and maintenance database to check for gas leaks throughout our hard pipe and also at the welding machines. And our manufacturing engineering performed random gas flow audits. All these tasks you see here were generated because of this project. Had we not done this project, we probably would have never seen a need for this. This is my welding gas charter. Again, we've listed the project name, significant aspect, the objective, target, and task and responsibility assignments. This is a gas flow audit documentation that's done by manufacturing engineering group, where they actually go out there and do a gas flow audit at the welding machines. Our cost of welding gas per standard hour decreased due to the increased gas leak awareness. In 2013, the average cost was $1.32 per standard hour. And in 2014, we actually set a target after that to get our costs down to $1.25 per standard hour. But we actually, in 2014, the cost was $1.23 for the year. So we exceeded our goal. And since June of 2014 through the end of the project at the end of May of 2015, our cost per standard hour went down to 85 cents per standard hour. As the cost went down, so did the usage. The usage in 2013, we were using 33.74 cubic feet of gas per standard hour. And in 2014, it went down to 30.94 cubic feet per standard hour. And since June of 2014 through the end of the project, at the end of May, it went down to 22.68 cubic feet per standard hour. All right, if you haven't listened to anything in this presentation before now, if you would, please listen to this. The green triangle indicates that we either met or exceeded our targets, our goals, and we did set measurable targets. Charter 1, kilowatt hours baseline created, were successful. Charter 2, we had a 71% improvement on electrical usage, so that was successful. Charter 3, 34% improvement in air leaks. That was successful. Charter 4, coolant used oil containment put in place. That was successful. Charter 5, well and gas costs decreased by 47 cents per standard hour. So all these projects were successful. You can set targets and you can achieve them. In conclusion, environmental projects enhance awareness to environmental aspects and impacts within our corporation. Contributions from all departments within the manufacturing facility are key to the success of environmental projects. Environmental impacts not only environmental issues, but also have a direct correlation to manufacturing operating costs and community appeal. That community appeal is key as well. MDEQ's enhanced program is a key contributor to the environmental impact awareness that's currently underway at Holmac. It's helped to create a corporate culture that is focused on the prevention of detriments that have a negative impact on our environment. And as a corporation, we look forward to our future association with MDEQ's enhanced program. Any questions for me? Thank you.
Thank you very much, Clarence. Part of the objective of having these presentations, as you may have noticed, is also to present to you best practices that a lot of your fellow peers in other industry in the state and educational institutions, for that matter, are taking advantage of. So hopefully it can spur some new ideas in your own facilities and what type of actions and projects you can undertake. Up next, we have another team presentation from Toyota, Mississippi. The three presenters are Linda Tucker, Philip Williams, and Mark Hildebrand. Linda has a Master's of Science in Industrial Technology from Mississippi State University. Linda has worked in various fields throughout her 12-year career, including manufacturing and refurbishment of helicopters, manufacturing of advanced unmanned systems and aerospace vehicles, and various manufacturing of ballistic and blast-protected vehicles. She has a career at Toyota since 2012, and her area of responsibility is the body weld department. She is also a current warrant officer in the Mississippi Army National Guard in the Jackson unit. Philip Williams has an industrial and instrumentation technology background. He spent the beginning of his career in construction industry building and commissioning chemical manufacturing facilities for various international companies, which led to his working at BASF for almost 15 years. He began his career at Toyota in 2007, where he was hired as the first team member for the Mississippi project, and currently he is the facilities mechanical engineering specialist, with main responsibilities being for all of the utility, equipment management, site infrastructure, and all of the site project management and support. Mark has a BS in mechanical engineering from Mississippi State University. He has worked in the manufacturing segments throughout his 30-year career, including textiles, aerospace, chemical, and HVAC industries. And now at Toyota, since at 2001, he's in the paint specialist area. So please welcome the Toyota team. And after this presentation, we will be breaking out of this room and going to the next room over for the award ceremony as well as the buffet. So hang tight.
Thank you. Good morning, my name is Linda Tucker. I'm a body weld production engineer specialist there at Toyota, Mississippi. Been there since 2012. I would like to thank Mr. Chris Messimer for Mississippi Department of Environmental Quality for giving us the opportunity to talk with you today here at the 2016 MDEQ workshop. Speaking at this event gives Toyota the opportunity to talk with you about its commitment to the environment. To get started, we will look at our North American operations, look at what is going on at our Mississippi plant, and then review our continuous improvement projects for waste, energy, water, implementations in our facility. By the numbers, we have 10 plants in the U.S., we have created 365,000 jobs, and we have been operating in the U.S. for 58 years. With a full investment of $21.2 billion. And as of today, more than 1.3 million vehicles have been produced in the U.S. with 9 different models, and the most popular being the Camry and the Corolla. Now let's talk about Mississippi. As you may well know, the start of the production in the Blue Springs facility was the fall of 2011. This October, we will be celebrating our 5th year anniversary. By the numbers, 170,000 Corollas are produced annually with $961 million total investment since 2011, and Toyota Mississippi has donated 10 training vehicles to local schools. Toyota Mississippi is one of 4 global sustainable plants. Toyota Mississippi strives to be the #1 in North America in environmental performance. Along with our business investment and commitment to safety and diversity, we are dedicated to improve the lives of our team members, enhancing the quality of our life for our customers, and tackling the challenging issues that exist in our communities where we operate. As an example, Toyota has committed $250,000 over 5 years for the investment in the Tombigbee State Park. Toyota Mississippi has donated 5,000 volunteer hours with $500,000 to area nonprofits. Now we will go into our technical presentations that will cover the continuous improvements at Toyota Mississippi. I'm going to start the presentation with our waste, Kaizen for respooling, then I'll give it over to Philip for our energy reduction project, and then Mark will finish us off with our water reduction projects. If you could, just save your questions towards the end of the interview, and the end of the presentations, and then we'll be more than happy to answer your questions. Body Weld Shop has a total of 9 Hobart MIG drums. We have 9 in our underbody line, and we have 4 in our main body line. Maintenance team members must change the drums when the MIG wire gets to a certain level so that they don't disrupt production, and those drums are then sent to be recycled along with the cardboard and the MIG wire that's in there. Disrupting production is approximately 15 to 20 minutes of our maintenance downtime for the change out of these drums. Body Weld, Kaizen, and offline repair shops currently purchase 7 MIG wire spools per month for offline repair and Kaizen projects that we do in our Body Weld shop. Each purchased spool by our Kaizen shop is $175 each. So what we did, we created several Kaizens for our maintenance team members so that they would understand when the MIG wire was at their certain level. We implemented an indicator light. We implemented a proc switch. So the proc switch, once the drum is moved out of location, it will trigger the light. Once the drum level of MIG wire goes down to a certain level, it will also trigger the light to come on as well. The top of the drum is normally just a complete cardboard top. What we did is we cut out the top and gave it a Lexan clear top so that maintenance could visually check inside. Also added a wire wizard guide to prevent from most of the burr and the tangles that was happening with some of the MIG drums. And we also implemented a quick release for maintenance for quicker change outs for their so that they wouldn't disrupt production as much. Team members still have to do their daily visual checks, but however, with all of these extra Kaizens, it's helped maintenance go a little bit further. So in trying to understand exactly what maintenance was going through as far as their disrupting production and us recycling so much copper wire, saw a need to implement a respooler. So this is a design that I worked with the Kaizen team. They built it for me, but what I did is I created, basically it's air operated. They can place the MIG drum inside, send it up. All they have to have is a 19mm wrench, take out the retainer and its bolt, feed the wire through, insert the retainer and cap, close the door. We always want to close the door for the safety of our team members, and they flip the switch, and this respools the excess wire that is being left in the drums. Currently, what is normally left in the drum is about 33 pounds of MIG wire. So in saying that, since the Kaizen, I was able to respool the drums. I was able to get the Kaizen and offline team respooled wire, and there was no need for the Kaizen team to purchase this wire. And as I said earlier, it's $175 per spool. So roughly about 7 spools per month is what Kaizen was spending on these. So it was $1,225 per month savings that I was doing. So a yearly savings was $14,700 for just the Kaizen and offline team. As far as the waste, because it was 33 pounds per drum of waste, that equaled 3,396 pounds, which in total that would equal up to 3 complete full drums that they were throwing away and recycling. I also implemented work instructions and PPE requirements for them to be able to utilize the respooler. Now I will turn it over to Philip for him to go into our compressed air Kaizen.
Thank you, Linda. My name is Philip Williams. What we have with the compressed air system, look at this more as a system than just about compressed air, because this is, when you hear the word Kaizen, please understand that that doesn't mean something is broken and you went and fixed it. It is about continuous improvement. You don't know that you have a problem until you go and collect data. Look at your data, analyze it from the first slide with the MDEQ, talking about the graphs. Sometimes when you collect a lot of numbers, until you put it in a graph form, you really can't visualize what's happening with the system. So please keep that in mind, and some of the questions that I ask myself when I go and seek Kaizen opportunities can be applied to water systems, gas systems, any kind of system that you operate and maintain. So we had a control system at our TMMS facility. It was local control, it was web-based, but it didn't allow you to actually collect any data. You could view data, you couldn't store data, could not even remote stop the piece of machinery or any kind of programming. So it required team members to visually go to the piece of equipment, handwrite, log, collect data. This really didn't provide us with much historical data collection whenever we had a problem. Very difficult to go back and trend to see what things were happening and taking place and be proactive to try to prevent issues. So we wanted to make that better and operate more for the ability of the plant to manufacture vehicles. And please note, this was working. This was not necessarily a problem. We were making vehicles, we weren't having any issues. So that kind of has the Kaizen mindset of improving. So after the Kaizen, we looked at installing, we actually designed our own custom program and put in place after talking to different manufacturers. Really didn't have what we wanted, so we built it ourselves. Now I have a remote control capability. It's on our internet system, so from any PC in the building, I can look at the compressed air system, I can turn things on and off. The data goes into a server based in our IS department, so it's every data point in the machine is going to the server. I can pull up and trend, look at historical data. That also provides me with the ability to put alarm points and give me warnings, so when things are happening on a compressed air system, I see it before it's happening and be proactive. And it allowed us the ability to start understanding the efficiencies and how we were using the system. So these are some of the questions that you can apply to systems when you're trying to find issues or make improvements. How much of a utility am I producing? In our case, it was compressed air. How much compressed air is being delivered to the customer? What does the customer actually need? And which machines, if you have multiple pieces of equipment with different efficiencies, are best served to utilize those at different times? So once we got our system in place, you could actually see that I started looking at the weekly usage of a compressed air system. Two distinct things really spoke out on the chart. And with a lot of numbers in place, it didn't stand out as much until you graphed it. And you could distinctly see on the weekends, we had a significant reduction in consumption, or what we needed to produce for the building, what was being used. The second opportunity is when we broke it down to a daily standpoint. We operate on 2 production shifts with space in between to allow for maintenance and overtime activities. Again, 2 distinct opportunities stand out. So with the new control system in place, we're actually able to go in and build a schedule to turn the machines on and off and actually operate the most efficient machine when it needed to be happening in place. So we're looking at what needs to be delivered, when we need to deliver it, and by what means we're going to use to deliver that to provide the best return for Toyota. So you can see on the weekends, we developed a schedule that actually shuts the large machines off, uses a smaller centrifugal or variable speed machine to deliver the lower demands. Same thing between shifts. Instead of running one machine, large machines continuously 24/7, look at your peaks and valleys, decide if you can use a smaller piece of equipment at that time and utilize that. Match the load with the most efficient machine, program it. The custom program that we built is a system that kind of thinks for itself. It looks at what's happening. Redundancies are built in the event of failures to start other pieces of equipment. What were our results from this? Almost 500,000 kilowatt hours reduction per year, 17,000 MMBTU, an annual cost reduction of almost $40,000, and in return a payback of less than a year, half a year. So ask why. When you're looking at your systems, we've heard several different people speak and make references to go to your facilities on the weekend when no one's there, your office when no one's there, and just stop and listen. What's running? Ask why it's running. We heard talk about HVACs and thermostats and control systems. Ask why your temperature is what it is. Ask, what rooms are occupied, what needs to be cooling, what doesn't need to be cooling. We heard reference of VFDs. VFDs are an incredible reference of saving. If you have a manual valve in a water process or some type of fluid process that you're controlling flow with, a VFD installation could save you up to 80% energy usage. So ask why. Don't let the abnormal become normal. Thank you. Turn it over to Mark Hildebrand now.
All right, thanks, Philip. Guess I'm the last one before lunch, so we'll keep it going. Along with energy and waste reduction, we also have water reduction, another one of our significant aspects that we really want to concentrate on. So one project we had was involving RO water. RO water is what we use for painting. It's similar to DI water. It's very pure, very low conductivity. We have to make RO water from just city water, non-potable. So this is kind of a simple diagram of just how an RO system set up. We take city water into a large tank. We currently run 200 gallons per minute non-potable into this RO system. And then from that, we generate 150 gallons of RO water and 50 gallons of waste. Basically, the water just feeds through the system, and we use the RO water, send it to the painting operations. 50 gallons of waste actually goes to wastewater treatment. So there's an opportunity right there. How can we improve our waste? 200 gallons in, 150 out, 50 to waste. Those are the key numbers. If we look at improved system, we added in a secondary RO system. Basically, this system here is actually takes the waste itself and runs it through a second system. It's a smaller system, utilizes a lot less floor space, a lot less energy. And what this RO system, the secondary RO system, we call it a concentrated recovery system. It basically takes all the waste, splits it out, and sends 25 gallons of that back to the city water tank. Very simple concept. You just run it through twice. So now our waste is cut in half. So now, instead of using 200 gallons to generate 150 gallons of RO, we use 175. So we're still getting our 150, only 25 gallons of waste. What does that mean in total in water savings? Okay, if you look at that on a chart, just taking a few months before we put in the change, July through January this past year, we were averaging around 208 gallons per vehicle. That's RO water used per vehicle. That includes all the painting, cleaning, E-code, everything. We put this system in February of this year, in the middle of the month, and immediately saw savings. And then in March, this last month, when we had a full month of savings, we were almost 60 gallons per vehicle saved, just resulting from that 25 gallon a minute saving because of all the cleaning and everything. The big number, if you put that in annual savings, is over 10 million gallons a year, which is quite a significant amount. And it allowed us to meet our internal company targets. The second project I had was in our pre-treatment system. This is a system that we use to clean the car bodies. It's the pre-treatment side is 11 stages. It's got rinses, degreasing chemicals, conditioner, phosphating, everything before we e-coat the vehicle. I've got a couple of photos I'll show to give a better explanation after this, but typically before situation, we have water is added to a rinse station, sprays off the degreased chemical. Anytime the conveyor is operating, the nozzles are spraying. There was 42 nozzles surrounding the vehicle, kind of in a halo form, which basically rinsed everything off. But there was a lot of water there, up to 60 gallons a minute flow there. The flow was controlled by operators who just manually opened the valve. So they could open it too much or not enough, and the water would vary, and we just didn't have a good control of our water situation. Afterwards on this situation,